So good afternoon, everyone. I hope you are enjoying the conference so far. I know this is the last one. You might be a little bit tired, but it's going to be quick, this one. So I'm going to talk about how we test our Puppet code using Docker at our company. So a little bit of background of me. I'm a software engineer, and I've been working for Reliant for 2 years and a half. And as a software engineer working with Rails, Ruby development, and also as a Puppet developer. I'm a Puppet user since 2010, when I started with Google Sum of Code, together with Puppet Labs. And I also started using container visualization for full OS since 2008. It's quite a bit time. So just to tell something about our environment, we have in total around 15,000 nodes. All of them are managed with Puppet, and these nodes are mostly small appliances that we sell for retail stores and food chains restaurants. And this appliance that we call as Redbox, it runs Debian, and we manage all the storage application using inside KVM machines and OpenVZ containers. Ooh. We also have some instances in Amazon EC2 as some background servers. So this is how our network look like. We split them in several sites. Each site is one customer of us. And for each site, we have the Puppet master that manages all the nodes configuration for that site only. We maintain our code in a private Git repository. And as soon as we have a new release, we push the changes from the Puppet source repository into the Puppet master, and then we wait until the agents pull back the changes. So we started using Puppet since the beginning, and Puppet gave us a really easy, high-level language to abstract our nodes environment, and that doesn't require a long learning curve, so that's a plus for us, and perfect for sysadmins that are not familiar with programming. But it is still a programming language. You still have to follow some development process and some guidelines and best practice. The code, it should only hit production environment when you know that it will work without any errors, and that it will also have the desired behavior, and that's really important. So the quality assurance that you have, there's several ways to do that, and some guidelines and tools available on the internet, on GitHub, on the Puppet Labs blogs and documentation. And it can ensure the correctness of your manifest in the production environment. So how many of you actually write tests for your manifest? Raise your hand. I was hoping that more people had raised their hand. I saw like 2. I'm going to ask this question later. So the first test that you have to do, I want to believe that everybody does that, is to check your syntax. We have some tools to do that. And depending on your IDE, on your text editor or Sublime, VI, or anything that you use, you can install any plugins to do that we call Puppet parse validate for your manifest every time you save it, or Puppet link that will automatically fix the most basic errors that you can find. And you can also, don't forget to check your YAML files and your template files. And one thing that I found out recently, it's the variable data type validation. It's very similar to Rails, if you are familiar to it, and it is available by the Puppet standard lib module, and You can verify any kind of, those are the functions available from that. And if anyhow the class you are implementing is misused, it's going to raise a Puppet pass error stating that this variable does not have the type of data that you want. So if you want to dig more on that, you can look at the NTP official model on the GitHub. It has a really nice usage of it. Smoke testing. For a very basic smoke testing, you can create just one line manifest that calls the class to be tested. In this example, it's the apt. And it will you can just run it with the Puppet apply and -- no op, just to ensure that the catalog will be compiled with no errors. But with this, you still have to look at the log to see if it's really being the way it should be. RSpec Puppet. For those familiar with Brody Testing, with RSpec, you can write the use case and context according to your task that you want to implement and ensure that your code is functional. We can take the apt model again, and this test is just to ensure that the source parameter is correct. It's going to apply the correct URL as a repository on the system. There is also kerr. There was an awesome talk yesterday. I don't know if anyone here attended to it. You should have. You write your RSpec test again, and you can apply it in many different kinds of operating system, and using any hypervisor that kerr supports, like Docker, Fusion, vCloud, and Vagrant. And in this example, also available from the apt module, it will just call the smoke test and ensure that it's still working with no failures. And after writing your RSpec test, you just specify your host in a YAML file, and this is also available, as I said, in the apt. You can specify the host and any other configuration. In this case, is for Vagrant. Yeah, but errors are still bound to happen. Forgetting to include a class or to set a variable may mean that the running Puppet on the host will fail and will not enforce the expected state that you wanted. So that's why we also do code review on our manifest. We use GitLab, and it's very similar to GitHub. You can submit a new merge request, which is equivalent to pull request on the GitHub. And we have a team responsible to review those pull requests on demand. So every time one new pull request is submitted, the code is reviewed by us and by any other developer from the team. And a lot of questions are asked between us to ensure that the manifest is sane. It is actually semantically correct. But because if you run Puppet, it doesn't raise any error, it doesn't mean it's the way, it doesn't mean it has the correct behavior. So that's really important. That's what I just said. So I'm going to ask again, how many of you use any tool that I just said? Oh, more hands. So that's some kind of level of testing that you do. But I can assure you that everybody in this room do test your code. Everybody tests your code on production. And why we do that? It's dangerous. It's not desirable to do that. Because most of the time, it's hard to translate into code, into RSpec tests, for example, what you see as a result from the Puppet run, and that you can actually see that it worked as the way you wanted. So you can see that every resource was created, every file was updated with the correct data, and that every service was started or halted or anything that changed. So this type of testing, you still have to have access, say SSH to the target node, and you still have to have access as root so you can run Puppet apply. That's not desirable. So the ideal is to mimic the production environment somehow. But that's not easy. And would be really nice to have a cheap way and easy way to mimic your production environment without jumping around between connections and hopping around any other systems. I see some heads nodding like that. So we developed Mustique. Mustique is a rogue gem that tries to recreate the target node using Docker underneath it. So Docker gave us a really fast, lightweight, and flexible way to create any operating system that, of course, Docker supports, independently on the host that you're going to test it as your local machine you are developing your manifest. And it is repeatable, it is isolated, and thanks to the Docker layering and caching, it is even faster the more you test it. Only the first one is going to be a little bit slow because they're going to fetch the containers and build any other structures that they have. So to use it with Mustique, we have basically 4 steps. You have to know the node's hostname that you want to create so that the Puppet master will know to which node it's going to apply the manifest. You can set a custom set of facts for that node, and you have to specify the operating system for it. For now, we just support Debian and Ubuntu, but it's still a work in progress. And that's it. So about the facts, you can write your own. You have to write in a text file, just specify the fact name and the value that it should be. This is just an example. If you wanted to set the domain of the testing node as, say, reliantsecurity.com, you can. Or, in an easier way, if you already have a node already in production, you can steal the facts from it. So you can just call Mustique fetch facts from my server. The first case there, the MAR server should be reachable from your machine, so it will use SSH to access it. Or you can set the host name of the node that you're going to be the target if it has a different domain that is going to be reachable from it. And you can also specify the user. If it's not the current user, you're calling Mustique. So it will generate this text file, and you can add or remove any order that you want. The third step is to specify the operating system, and just Ubuntu and Debian. There is a Ubuntu above 10.04, I guess, something like that. I'm not sure right now. And this is the most basic way you can use Mustique. If you really want to run it for a brand new node, it will fetch the container and will set the host name as my server, and underneath is going to apply the Puppet. But and if you stole your facts, you can just pass the custom facts as using --facts parameter. But how does it actually work? How Mustique is using Docker underneath? That's the interesting part. It creates a Docker file for each OS that is supported. This is an example for Debian. And the base doc files is already shipped with Mustique. It retrieves from the Docker the official OS containers. As in this example, it's getting the official Debian flavor with one. And in the next line, you can see that we are installing Puppet and Puppet master on the container. Oh, sorry. Yes, that's correct. So the Puppettard that was on it's on the last line here. It is generated from the files, the templates, manifests, and modules from your kerr directory. It just zip all together and is going to pass to the container. What is important here is the on build. It's highlighted there. It doesn't actually copy the file during this Docker, the build of this one. Mustique is going to create a second Docker file, and the on build, which is just a trigger, is going to copy once Mustique builds a new container using this Docker file here. It is a custom Docker file for the node to be tested, and it starts on the third line, as you can see, it starts Puppet master process, and then we'll call the Puppet agent to apply the manifest to that node. So the output of the Puppet run returns back to Mustique that will parse and displays it as a small, it's quite simple right now, summary of it. It will highlight and it will return a callable 0 if it does have any errors detected. So if you integrate with your CI, for example, it can detect it actually failed. But you can also run with -- verbose. So it will output all the logs actually, and it will pass the verbose and debug flags to the Puppet run. Why not kerr, you may ask? Kerr also supports Docker, but one of the main reasons Puppet is so popular is because it doesn't require programming skills. And at the same time, the kerr testing tools, it requires some of those skills. You have to know how to write a good test, which is not easy, that will catch all the cases that you want to do it. And sometimes the developer only wants to make it work. Let's see if it actually worked really quickly. I'm not going to say that losing time writing tests because it's also important, but sometimes you don't have time to do that. So Mustique works out of the shelf. The only requirements for it is Ruby and a Docker container somewhere that you installed. And with that, you can avoid the learning curve of any other tool. And by running more tests, it's also more code that your developer has to maintain, and it's also more time, and it's kind of a snowball. So what can I do with it? It's pretty basic. You can integrate with CR preference, and you can add as let's say every push you do to your code repository will trigger a new Docker container test and return back to you the results of it. You can also speed up your development process since you won't depend on connectivity to your target machine. Sometimes you have to have the SSH pending there forever. Sometimes your connection isn't that good. It's slow. And the node actually doesn't even have to exist. You may be planning on deploying a huge set of nodes that doesn't yet exist. You don't have to pay, say, Amazon EC2 for a new instance just for testing, which is good. And most importantly, no more testing production. So, as I said, Mustique is still a work in progress. It's pretty basic. And we have a huge roadmap, and any feedback is really appreciated. And some of the future steps are copying the resources from an existing node. So we know all the services running, and we can actually mimic the full node. We have to extend the support operating systems that for now it's only Debian and Ubuntu. One thing that's important to us is the ability to specify the Puppet version. For now, it's just fetching the latest version of the Puppet available on the operating system official repository, which is not always the same one that you are using in your environment. One very curious thing and most challenging, I think, is going to be multiple nodes testing. We can link multiple containers with different servers and see how they are working together, if they are configured all the same system. And it also use an existing Puppet master. So the Docker doesn't even need to spin up a new Puppet master for every task that is right now. So that's it. Thank you very much. You can see. That's the repository, but the code isn't there yet. So I promise. I promise it's going to be around the beginning of the next month. So you can follow me on Twitter and send me emails about it.
We've finished a little early, so we've got time for questions. So put your hand up if you have any questions, and I'll run a mic down to you. No questions? Okay.
No questions.
Carla, thank you very much.